Okay friends, welcome to this lecture. In this lecture, we are going to see two important methods to solve a linear system of equations. Although we have seen how to solve m equations in n unknowns with the help of row echelon form technique or row reduced echelon form technique. Today we are going to see two different techniques. First one is called Gauss elimination method and other we shall see Gauss Seidel method, and we shall see what is the basic difference. So, these two methods that we are going to discuss today, Gauss elimination method and Gauss Seidel method, these two methods are valid only for n equations in n unknowns. If we are having m equations and n unknowns, number of equation is different from number of unknowns, then these two process or these two methods cannot be applied. So, first restriction is that number of equations is equal to number of unknowns. So, we are having n equations and n unknowns. Okay. And these equations are here in fact a11 into x1 plus a12 into x2 and so on and so forth plus a12 nn into xn is equal to b1. This is the first equation. And similarly, we are having second equation, third equation and nth equation, where these x1, x2, x3, xn are unknowns. We are supposed to find it out, and these aij's, a11, a12 etc. these are already well known in advance, and b1, b2, bn they are also well known given quantity. Only x1, x2, xn these are n unknown quantities. We are interested what are the solutions of this system of equations. Okay. So, A is the first step, it is exactly similar to that we have seen row echelon form or row reduced echelon form. First step is that write this matrix, write this into the matrix form, or better it will be say that write the augmented matrix associated with this system of equations. What is the augmented matrix? Augmented matrix is first you write the coefficient matrix, then the last column will be the known quantities b1, b2, bn. That is your augmented matrix. This augmented matrix we are aware of from the first two lectures. So, look at here, this the matrix B which is lying here, this is our augmented matrix. Okay. So, up to here this is our the matrix A, that is a coefficient matrix, and the last column if you see here from here b1, b2, bn, these are the RHS part of the given equations. So, this matrix B is called augmented matrix. Okay. So, first step is that if n equations, n unknowns are given, write the corresponding augmented matrix. Very simple. So, first you write the coefficient matrix. First row will be a11, a12, a1n, second row a21, a22, a2n, and so on and so forth. Nth row is an1, an2, ann. So, this is the coefficient matrix A. Then write one more column in this matrix, that is b1, b2, bn. So, in this way we are in a position to write the associated augmented matrix of the linear system of equations. So, I believe that if n equations, n unknowns are given, then we can write, or you can write the associated augmented matrix immediately. So, I assume that now B is known to us. So, this augmented matrix is known to us, and when this matrix B is known to us, then we are going to convert this matrix into an upper triangular matrix, not a lower triangular matrix. Let me correct here. So, whole process is convert the matrix A, not the matrix B, into an upper triangular matrix. Okay. Then we shall use the backward substitution to get the solution. What is the meaning of backward substitution? First of all, we are interested to know what is the value of x1, x2, x3, xn. So, first of all xn will be known. when xn will be known, then xn minus 1 will be known with the help of xn, and when xn and xn minus 1 are known, then xn minus 2 will be calculated, and so on and so forth. Finally, x3 will be calculated, then x2 will be calculated, and in the last x1 will be calculated. This is our backward substitution. So, whole thing is that how to convert the matrix A means the coefficient matrix into an upper triangular matrix. So, see what is the process. For first of all, we shall choose, first step is to choose the pivot element. What is the meaning of pivot element? Look at the first column of the matrix B. Okay. And what is the numerically largest value? What is the numerically largest value? As I told you, suppose somewhere it is in the first column, one entry is 8, other entry is minus 12. So, we shall take minus 12 as the numerically largest value. So, that is the pivot element. So, choose the pivot element which that is the absolute largest value in the first column of the matrix B, and if required we can interchange the row. What is the meaning if required? Interchange the row so that pivot element it comes at the first position, at the position where A11 is sitting, means the first column at the first row where A11. So, the pivot element should be there. So, therefore, if A11 is the largest, if numerically largest, then it is the pivot element, and if it is not, then look at the first column, which one is the numerically largest. So, interchange the row so that you can bring the pivot element at the position of A11. Okay. Then multiply the first row, look at multiply the first row by AI1 over A11. Remember here A11 should be always numerically largest, it should be different from 0. Why it should, why A11, that is numerically largest value should be different from 0? Because you are having n equations, n unknowns. So, either A11, even if A11 is 0, then look at here A21 or A31 or AN1. Out of these, one element has to be different from 0 because it is n equations and n unknowns. Therefore, you can assume that the pivot element has to be different from 0. So, therefore, we shall multiply the first row by AI1 by A11. Then you subtract whatever we are getting from the ith row. Then you see what happens. So, the element below A11 in this process will be coming to be 0. I shall explain in the blackboard, just wait for some time. So, this Li1 is AI1 by A11. So, what is L21? L21 means A21 over A11, A21 over A11. Multiply the first row by A21 over A11, then subtract from the second row, you will see that you will get the entry 0 below A11. Then L31, what is L31? A31 over A11. Again multiply the first row by A31 over A11, subtract from the third row and continue this process. See that all elements below A11 will be 0. And repeat these two steps, and then repeat these two steps for second row, third row and nth row, and so on and so forth. We shall see that finally the matrix A will be converted into an upper triangular matrix. After that we shall use backward substitution. I shall go on the blackboard, then I shall explain how we are converting the matrix A into an upper triangular matrix. Okay, I believe that at this stage how to convert the matrix A into an upper triangular matrix may not be very clear unless we shall see it on the blackboard very clearly. So, look at here the matrix B, that is the augmented matrix. I am writing the matrix B here, that is the augmented matrix. A11, A12 and so on and so forth, A1n, A21, A22 and so on and so forth, A2n. I shall put one more, A31, A32 and so on and so forth, A3n and so on and so forth. This is your A, N1, An2, Ann, and the last column is in fact B1, B2, B3, and Bn. This is the augmented matrix. Okay. So let us see how we are going to convert the coefficient matrix A into an upper triangular matrix. So choose the first step is choose the pivot element. What is the pivot element? Look at here, the first column, look at here, A11, A21, A31, A41, An1. See which one is the numerically largest. Means take the absolute value of A11, A21, A31, An1, see which one is the largest. And then bring that one, suppose that A31 is the largest, numerically largest, then interchange third and first row. Okay, interchange third and first row. So this element will be coming here. So numerically largest value will have to bring at the position of A11. So suppose by interchanging the row, we have brought the pivot element at the position of A11. So this is our pivot element. Okay. Now, the moment this pivot element is decided, then do not touch the first row of the matrix. So A12, A11, A12, A1n, B1, then this one we shall not touch at all. Remember that this A11, it might have been interchanged, then it had come here. So now we want the moment this one is pivot element, we want that this element should be 0, A21 should be 0, A31 should be 0 and A11 should be 0. Every element below pivot element should be 0. Okay, how to bring this one to be 0? So for that one, look at here, I am writing here A21 by A11. Multiply the first row by A21 by A11. Remember, A11 is different from 0. So therefore, if you are multiplying the first row, means everything A11, A12, A11, including this B1, has to be multiplied by this A21 by A11. Therefore, what will happen? Look at here, this A11 will be cancelled. We will get A21 here. Okay. Then subtract the resulting output from the second row. Look at here. So multiplying the first row by A21 by A11, then subtract it from the second row. Therefore, this has to be there 0. Therefore, this A21 will become 0. This is your pivot element. So A21 will be 0. Now, again we want this one to be 0. So multiply the again first row by A31 by A11. A31 by A11. Multiply the first row again by A31 by A1 and subtract from the third row. Everything, all these things has to be multiplied by A31 by A11, subtract from the third row. So look at here, again this will be 0. And continue this process. Finally, multiply the first row by AN1 over A11, AN1 by A11. Multiply the first row by A11 over A11 and then subtract from this nth row. Then you see that again this quantity will be 0. Okay. Now look at here. This A11 is different from 0 and below this every element is 0 now. Okay. Now look at the second column from here onwards. We shall not change, we shall not touch the first row at all. It will remain as it is. Now look at here, A22, A32. Now this A22 is not the same A22 that was in the first. Now it has maybe something else, some other number. So see the second column, here, up to here. Then again choose the pivot element. Means what? See which one is the numerically largest. If required, interchange and bring this one at this position. So this is again the pivot element. Then again before this pivot element is A22, the moment this is decided pivot element, then below this pivot element all elements should be 0. So what we shall do? Multiply the second row by A32 over A22. The second situation will be A32 by A22. Multiply the second row by A32 by A22 and subtract from the third row. Okay, see that this element will be 0 and continue this process so that look at here, all elements below this diagonal elements will be 0. Okay, and when is it 0? Look at here, this is 0, everything is 0 except ANN into BN. So ANN into XN is equal to BN, and therefore xn is equal to bn over a nn, although this bn and this nn will be totally different from the original situation. We shall see some example, then it will be much more clear. Now we have seen how to convert the given matrix A into an upper triangular matrix. The process that we have seen, that is called Gauss elimination method. Gauss elimination with partial pivoting. This process is called Gauss elimination with partial pivoting and without scaling. What is the meaning of without scaling? Again I shall explain in a short while. So look at here, what is this Li1 that we are multiplying by the quantity ai1 by a11, that is L21, L31, Ln1 and so on and so forth. These are called multipliers. These are called multipliers to create 0 below the pivot element. And then you can see that the original matrix A can be written as product of L into U. What is L? I shall explain. The original matrix A is in fact the product of two matrices L into U. L is unit lower triangular matrix. Unit lower triangular matrix. What is the meaning of unit lower triangular matrix? It is a lower triangular matrix. Lower triangular matrix means see the main diagonal elements and above that all elements are 0. That is lower triangular matrix. And what is the unit lower triangular matrix means? All elements on the main diagonal are 1. That is the meaning of unit lower triangular matrix. So L is a unit lower triangular matrix. So all main diagonal elements are located here in this matrix are 1, and this is our L21, L31, Al1. What is L21? This is the multiplier which has been, L21 is multiplier which has been used to create 0 below A11. Similarly, L31 is also a multiplier, Al1, all these Lij are multipliers. So this L is unit lower triangular matrix and U is in fact the upper triangular matrix that has been obtained with the help of Gauss elimination process. Look at here, now A is equal to L into U. Therefore, determinant of A is equal to determinant of L into U. But the determinant of L into U is determinant of L into determinant of U. But what is determinant of L? L is unit lower triangular matrix. What is the determinant of a triangular matrix first of all? Determinant of a triangular matrix is the product of all elements, product of all diagonal elements. Okay. So determinant of a triangular matrix is equal to the product of diagonal elements. Fine. So look at here, the moment any element is 0 on the main diagonal, therefore the determinant of that determinant of that matrix will be 0 immediately. If there is any element 0 sitting anywhere on the main diagonal. And L is a unit lower triangular matrix, unit lower triangular matrix. And when it is a unit lower triangular matrix, therefore all elements on the main diagonal are 1. Therefore, what is determinant of L? Product of all diagonal elements. So therefore 1 into 1 into 1 and so on and so forth. So therefore determinant of L is 1. And therefore determinant of A will be equal to the determinant of U. Okay, determinant of U. And what is determinant of U? That is U11, U22, U33 into UNN, that is product of diagonal elements in the upper triangular matrix U. But when no row we have interchanged, when no row, if row are interchanged for creating 0, then it will be minus 1 to the power m, then determinant of A will be minus 1 to the power m into the product of diagonal elements. So if once we have interchanged the row, then it is minus 1 to the power 1, that is minus of that quantity. If 2 times we have changed, then it is minus 1 to the power 2 and so on and so forth. So that is, if no row has been interchanged, then determinant of A will be U11 into U12 into U33 and so on so forth into UNN, and if m times number of rows are interchanged, then determinant of A will be minus 1 to the power m into product of the diagonal elements of the matrix U. In this fashion, we can find also the determinant of any matrix A. Let us see one example. Gauss elimination method with partial pivoting and without scaling. Without scaling, I shall explain in a short while, but not at this stage. So, this is the matrix, three equations, 3 unknowns, it is given to us, and we want to solve this equation. Okay. So, then what is the first step? First step is that write the associated augmented matrix B. So, look at here, this is the augmented matrix B. So, this one up to here, it is the matrix A, coefficient matrix A, and this is 1 3 2, it is B1 B2 B3. So, augmented matrix is known to us at this stage. Now, we want to convert this matrix A into an upper triangular matrix with the help of Gauss elimination. Then what is the technique? As I told you that you look at the first column, this is your first column, and what is the numerically largest value here? Numerically largest, the first column minus 1, 2, 4. So, 4 is the numerically largest value. Therefore, we shall interchange this first and third row. First and third row we shall interchange. Okay. So, first row will be 4, minus 1, 2 and 2, and third row will be minus 1, 2, 2 and 1. So, let us interchange, so that this 4 will be the pivot element. So, look at here, now we have interchange first and third row, and then we are getting this. Now, remember here, as I told you, the moment pivot element has been decided, now we shall not touch at all the first row. So, first row is 4, minus 9, 2 and 2. So, this row we are not going to touch. So, now we want that this 2 at the place of 2 should be 0, minus at the place of minus 1 it should be also 0. So, therefore, use multiplier. What is multiplier? L21 is this 2 divided by 4, 2 divided by 4. So, multiply the first row by 2 by 4, that is half. This is your 2 by 4. So, multiply the first row by half. Then what? Then subtract from the second row. See that you will get here 0. Multiplying by first row by 2 by 4 means half. So, half means multiply. So, 4 will be here 2, minus 9 by 2, 1 and 1. Subtract from the second row. So, here it is 2, then 2, you will get 0 here. So, here it is minus 4, and look at here, minus 4, and this will be multiplied by minus 9 by 2, so minus 4, then minus of minus 9 by 2. See that what we are going to get? Are we going to get here half? We are going to get half here, and so on and so forth. Similarly, multiply the first row now by minus 1 by 4, minus 1 by 4, then subtract from the third row. Subtract from the third row. See that again you are going to get here 0. So, look at here, this 4 is the pivot element, 4 is the pivot element, and below all entries are 0. Now, look at here the second column. Second column we shall see only this part up to here only. See which one is the numerically largest value. Half and minus 1 by 4. Half and minus 1 by 4, which one is numerically largest? 1 by 2 is the numerically largest. So, therefore, there is no need of changing rows. Okay. Then we want that minus 1 by 4 should be again 0. How minus 1 by 4 will be 0? So, therefore, we shall see what is the multiplier, then L32 will be minus 1 by 4 divided by half, that is our minus half. So, multiply the second row now by minus half and subtract from the third row. Automatically look at here, this will be 0. Okay. Now, we are going to get an upper triangular matrix. Your job will be over. Very simple. So, with the help of this process, see that we are going to get this matrix A. This matrix A has been converted into an upper triangular matrix. The moment it is converted, the matrix A is converted into an upper triangular matrix, then use backward substitution. What is the meaning of backward substitution? Look at here. See the last row. 0 into x1 plus 0 into x2 plus 4 into x3 is equal to 5 by 2. So, 4 into x3 is equal to 5 by 2, therefore, x3 is equal to 5 by 8 known to us. What is the second? Then you say the second row, half into x2, 0 into x1 plus half into x2 plus 3 into x3 is equal to 2. And look at here, x3 is already calculated, and therefore, x2 you can calculate from here, see that x2 is equal to 1 by 4. And then from the first row, that is 4 into x1 minus 9 into x2 plus 2 into x3 is equal to 2. Now, x2 and x3 are known, therefore, x1 will be calculated from here, see that x1 is also coming to be here 3 by 4. So, see that x1, x2, x3 are calculated. This process is called Gauss elimination method with partial pivoting, but without scaling. So, I am going to now explain what is the meaning of scaling. Now, we have seen that how to convert a matrix A into an upper triangular matrix with the help of Gauss elimination with partial pivoting, but without scaling. And now, let us see next example. But before that, let us see one. I have told you how to find the determinant of the matrix. Look at, suppose the matrix A is given to us, then how to find determinant of the matrix? Determinant of the matrix is the determinant of U. Look at here, and what is U here? Look at here, upper triangular matrix is U, that has been obtained from here. This matrix is your U. This matrix is our U, upper triangular matrix. This matrix is our U. And what is the matrix L? L is, look, remember, L is unit lower triangular matrix. So, all elements on the main diagonals are 1 and other elements are the multipliers L21, L31, L22 and so on and so forth. Look at here, remember what are the multipliers in fact. Remember these multipliers that we have used, that is 2 by 4, minus 1 by 4 and minus half. These 3 multipliers we have used. So now, then you see what is LU decomposition. U is this matrix, that is upper triangular matrix that has been obtained from A with the help of Gauss elimination with partial pivoting, and this L is the unit something. This is your 0. This is our 0. This is also 0. This is also 0. So, this is our 0. So, this is L is our unit lower triangular matrix. Remember here, these 3 elements are 0. So, all elements on the main diagonals are 1 and these are half, minus 1 by 4 and minus half, these are multipliers. So, L into A will be equal to L into U, and therefore, determinant of A will be product of the diagonal elements of U, that is 4 into half into 4. But remember here, once we have interchanged the row, when row has been interchanged once, so therefore, minus 1 to the power 1, therefore, it is coming to be the determinant of the matrix A is minus 8. So, in this fashion we can find the determinant of the matrix also. Let us see Gauss elimination with scaling and with partial pivoting. The meaning of scaling now I am going to explain. Now, suppose these again 3 equations, 3 unknowns are given on the slide, and we want to solve these 3 equations in 3 unknowns, this system of equations. We want to find what is the value of x1, x2, x3. Although you can check that x1 is equal to 1, x2 is equal to 1 and x3 is equal to 1 is the exact solution. So, if you substitute the value of x1 is equal to 1, x2 is equal to 1, x3 is equal to 1, we are going to see that LHS is equal to RHS for all the 3 equations. Let us see how we are going to find this solution with the help of Gauss elimination with scaling and partial pivoting. So, step 1 is exactly same, that write the associated augmented matrix. Associated augmented matrix. So, write the first one, this is your augmented matrix, B is our augmented matrix. Means what? What is augmented matrix now? Up to here, look at here, it is the matrix A, coefficient matrix, and the last column is B1, B2, B3. So, augmented matrix is known to us now at this stage. Then do the scaling. What is the meaning of scaling here? Now, I am going to explain. Scaling means we are going to normalize each row. What is the meaning? Normalizing each row of the matrix. We are going to normalize matrix A, not the matrix B. Remember here, So, normalize each row of the matrix A means what? The largest element in every row should be 1, not more than that. So, largest element in any row of the matrix should be 1, then we say that the matrix A is in the normalized form. So, what is the meaning? Look at here, the first row is 0.00345, this is the matrix A. Look at here, although second element is 9 also. So, we are not bothered about 9, we shall see here the entries of the matrix A, first row of the matrix A, which one is the largest element is 5, but it has to be 1. Therefore, what we shall do? We shall divide each row by 5, so that this 5 will be 1 and other element automatically will be less than 1, because it is the largest element. The moment we are dividing each element of the first row by 5, then remember that we should not forget to divide this B also, this 9.003 also by 5. So, divide first row by 5 or multiply the first row throughout by 5. Then this first row will be in the normalized form. Similarly, you see the second row, it is minus 3, 3.85, minus 6.75. So, minus 6.75 is the numerically largest. Absolute value, in absolute value it is largest. So, therefore, this multiply the second row by minus 6 by 1 over minus 6.75 or divide the second row by minus 6.75, so that it will be normalized form. In third row, if you look at here, 4 minus 5.25 minus 3.5. So, this one is numerically largest, minus 5.25. Therefore, divide this row also by minus 5.25. So, this is the, then we say that this is scaling. This is called scaling, that is normalization of the matrix A. So, look at here, now we have divided the first row throughout by 5, second row by throughout by minus 6.75, and third row we have divided throughout by minus 5.25. Okay. So, let us see what the resulting matrix is there. See, the resulting matrix is coming here after dividing. Now, it is in normalized form. Why it is in normalized form? Look at this matrix A. Highest element in every row is 1, 1. Here it is 1, here it is minus 1. Although even if it is minus 1, we can, let me check. This should be, look at here, minus 5.25, minus 5.25 by minus 5.25. So, this is 1 in fact. So, this is 1. So, this is plus 1. Okay, this is plus 1. Now, this matrix A is now in the normalized form, because if you look at the highest element, numerically largest element in each row, it is 1. 1 here, 1 here and 1 here. Now, scaling is over. The moment scaling is over, go back to the Gauss elimination method with partial pivoting. Now, process is exactly same that we have seen in the previous Gauss elimination method with partial pivoting. Do the partial pivoting means what? Look at the first column. Look at the first column of the matrix. Which one is numerically largest? That will be your pivot element, and bring that element at the position of A11. So, which one is? Look at here, 0.7619. This is numerically largest. Therefore, it has to come at this position of A11. So, therefore, interchange first and third row. So, when you interchange first and third row, look at here, this matrix has been obtained. First and third row has been interchanged. So, now 0.7619, this is our pivot element. Then what is the next step? Below this pivot element, every element should be 0. So, this should be again 0 and this should be also 0. Create 0. Create 0. How to create 0? See again the Gauss elimination method. Find multipliers means what? How we will say make this one to be 0? Multiply the first row by 0.4444 divided by 0.7619. Then subtract from the second row. You will get here to be 0. Again, for here, multiply the first row by 0.0006 over 0.7619, then subtract it from the third row, you will get here 0. So, 0 is created. the moment 0 is created, then go to the second column. So, I believe that you can create 0 below the pivot element. So, look at here, now 0 has been created with the help of multipliers. As we have seen in Gauss elimination method, 0 has been created. Now, look at the second column now. Second column means we shall, as I have told you in the Gauss elimination method, the moment pivot element is decided, we shall not touch at all the first row of the matrix. So, therefore, look at here, which one is again numerically largest? Look at here, 0.80079, it is the numerically largest. Therefore, we will have to interchange the row. So, interchange second and third row. Interchange the second and third row, it has come here. Okay. Then again you want this one to be 0, this one you want to be 0. How to create 0? Create 0 here means what? Multiply the second row by how? How we are going to multiply the second row by 0.01296 over 0.80079. Then subtract it from the third row. You see that you are going to get here 0. Okay. In this way, see that this matrix A, the matrix A has been converted into an upper triangular matrix. So, this matrix A has been converted now into an upper triangular matrix. Look at here. Now, this is the matrix A, which is now into an upper triangular matrix. Then use backward substitution. Backward substitution means this 1.3727 into x3 is equal to this quantity. Therefore, x3 is calculated from here. Again, from here, this into x2 plus 1.005 into x3 is equal to 1.8013. So, now when x3 is known, therefore, x2 will be calculated from here. Then from the first row, see that 0.7619 into x1 minus 1 into x2 minus 0.66667 into x3 is equal to this quantity. From here, x1 and x1 will be calculated because x2 and x3 are already known at this stage. Therefore, you can see that x1 is this, x2 is 1.0001 and x3 is also 1.0001. Remember that we have seen that exact solution of this system of equation is 1, 1, 1. We are using here Gauss elimination method with partial pivoting as well as scaling also, and we are going to get the solution. Look at here, this solution is very, very close to the exact solution 1, 1, 1. Question arises, what happens if we do not use scaling? If we do not use scaling, then again we shall get an approximate solution, but this solution may not be very, very close to the exact solution. So, let us see if we are not using scaling, or if we are not normalizing the matrix A, then what happens? See here, same matrix, same system of equation we are going to see, but we are using Gauss elimination method with partial pivoting. Only scaling we shall not use. Scaling we shall not use means we shall not normalize each row of the matrix A, and we shall use as usual the Gauss elimination process with partial pivoting. That is the basic difference. So, look at here, this is the augmented matrix. Here we shall not normalize the each row of the matrix A, means what? We shall not divide the first row by its by the element which is largest in magnitude. We shall not divide the first row by 5. Is in the second row we shall not divide by minus 6.75. In third row we shall not divide by minus 5.25. It is as usual. We shall use now partial pivoting, means just look at what is the numerically largest value. Numerically largest value in the first column, numerically largest is 4. Bring it at the position of A11. So, therefore, interchange first and third row. See, this first and third row has been interchanged. So, we are getting this one. Okay. Now, this 4 is the pivot element. This 4 is the pivot element. Therefore, now first row we shall not touch at all. Okay. Now, below 4 we want all elements to be 0. So, in place of minus 3 we want 0, and in place of 0.003 we want to be again 0. So, how to create 0? Use the help of multiplier. Means what? Again minus 3 by 4. What is the first multiplier? Minus 3 by 4. Multiply the first row by minus 3 by 4. Okay. And then subtract from the second row. look at here, minus 3 by 4 multiplied by 4, you will get here minus 3. Subtract from the second row, look at here, you will get here 0, and so on and so forth. For this one, what is the next multiplier? 0.003 divided by 4, that is a multiplier. So, multiply the first row by 0.003 by 4, then subtract from the third row, see that you will get here 0. So, look at here, we are getting 0 here. Sorry, I shall come back here, the 0 here. Then come to the second column here. Second column means again first row you shall not touch. Look at this part only, this part only. Which one is numerically largest? Look at here, 4.0039 is numerically largest here. So, therefore, we will have to interchange the row. So, interchange the row. By interchanging the row, you see that second and third row had been interchanged, and we are going to get this one. In this case, this is your 4.0039 is the pivot element. When it is a pivot element, below this one you want to be 0. How to create this 0? Again multiply the second row by 0.0875 divided by 4.0039. Okay, then subtract from the third row, or automatically this element will be 0. That is the process how to create 0. So, I believe that this 0 has been created, and finally, we are going to get an upper triangular matrix. So, look at here, now an upper triangular matrix has been created here, and from here use backward substitution, see that x3, x2 and x1 we are going to get. Exact solution is 1 1 1, see that it is of course close to 1 1 1, but it is not very close in compared to the previous method that we have seen, scaling and partial pivoting. So, therefore, if you want a better approximation, better solution, then we shall use Gauss elimination method with scaling as well as with partial pivoting. It will give you a better solution.